Hello everyone, my name is Kathan and today we'll be discussing the problem tasks and deadlines from the sorting and searching problems of the CSES problem set. Let's begin. Let me read out the question for you. You have to process n tasks. Each task has a duration and a deadline. You will process the tasks in some order, one after the another. Your reward for a task is D minus F, where D is the deadline and F is your finishing time for that job. And the starting time is 0. So initially you can say the timer starts at 0 and you have to process all the tasks, and the reward that you get for a task is D minus F, where D is the deadline for this task and F is the finishing time in your schedule for this task. What is the maximum reward you can get if we act optimally, right? So we want to actually schedule this task in a way that summation of this D minus F, right? So you just sum all the rewards of individual tasks is maximized. So input here, you can see first line will be integer n, representing the number of tasks. After this, there are n lines that describe the tasks. And how is the task described? First, you will be given its duration, right? So A will represent duration, and then D will be the deadline, right? And all the, you can say the schedule starts at 0. So initially you are at 0, and now you have to schedule all the tasks. And for each task, you will get a reward, which is D minus F, D being the deadline and F being the finishing time in the schedule that you decide. So we have to schedule all the tasks, right? And what you have to output is the maximum reward we can get, right? So we want to give an optimal schedule in which the reward is maximized. Output print one integer, the maximum reward. Fine. So I'll take the example test case and constraints on the iPad, but I guess the question is clear. We are given some n tasks, each are described by a deadline, and each are described by duration and a deadline, and if you want to schedule it in a way, the reward function, that is summation of D minus F, is maximized. Let's move on to the iPad and discuss this question a bit more. There is one important thing I hope you have noticed in the question, like we have to process the task even if it yields a negative reward, right? So even if D minus F in your schedule is negative, you still have to process it. So you have to schedule the end tasks no matter what, right? So reward being negative doesn't mean you are not gonna put it in the schedule. Fine. So let's discuss the constraints here first then. N was as high as like 2 into 10 power 5, right? This simply says that if you try to do a order of n square solution, it's gonna consume you what? About 10 power 10 operations, right? But you cannot do more than 10 power 8 operations in 1 second time limit, which is for this question. So n square doesn't work. Then n log n, yes, n log n works. Order of n, yes, it works. Something better than that, right? So you have to think in this direction. N log n, and so on and so forth. Fine. Let's look at example test case and try to understand this question. In the example test case, there were actually 3 tasks, right? So n equals to 3. So first n of input will be 3. You have 3 tasks at your hand, and then each task is described by 2 things. What is this? So first you'll be given a duration, and then you'll be given a deadline. Let me just call it as dur and dl, right? So for each task you'll be given these 2 things. So they were 6, 10, 8, 15, 5, 12. So what does this mean? The 6 means the first task has a duration of 6 and deadline of 10. Second task has a duration of 8 and a deadline of 15. And third task has a duration of 15 and a deadline of 12. And all the tasks start at 0, right? So initially you start scheduling the task at 0. Now you have to find me the optimal reward. In other words, you find me a schedule which yields the optimal reward, or you can say the maximum reward. And what is the reward, guys? The total reward is summation of di, summation of dl of I minus f of I, right? F of I means the finishing time in your schedule. Now what is the optimal schedule here? This is how the optimal schedule will look like. So initially we start at 0, okay? And now we schedule the task which has a duration 5. So this guy has a duration of 5, but this guy's deadline was what? 12. Okay. Then we schedule the task whose duration is 6. So this will be at 11, but this guy's deadline was 10. So this was 5, 12. This was 6, 10. And then the last task is remaining, which will be 8, right? So 11 to 19. So 8 was the duration and 15 was the deadline. Now what is the reward here? So for this guy, the reward will be what? So it ended at 5, but it ended at 5, but his deadline was 12. So the reward that you'll get here is D minus F, 12 minus 5. For this guy, its deadline is what? Deadline is 10, but it ended at 11. So the reward you'll get will be 10 minus 11. I'm just doing DA minus F, like DL minus F. So deadline minus the finishing time in the schedule. And for the last guy, we are going to incur a negative reward here as well, right? So It was supposed to get like the deadline was 15, right? But it got ended at 19. So 15 minus 19. So what is it? It is 7 minus 1. So this is minus 1 and this is minus 4. So all in all 7 minus 5. So 2. So 2 is the optimal reward here, right? So you cannot do better than this. So that's why. Let's move on to discuss the approaches then. How are you gonna actually approach this question then? Now you might think that this is a sorting and searching section, so let's just think about sorting something. But okay, this is not a good approach. You will not know this in any random competitive programming question. Instead, let's try to build our intuition step by step, or approach this question, as Priyansh would say it, from first principles. Uh, what do we have here? So we have two parameters at play. First is duration, and then another one is deadline, right? And a reward function for a given task is simply d minus f, right? Now let's try to sort these jobs in a way that it makes the input more amenable or more simple to look at. Now if you see the reward, it directly depends upon deadline, right? It directly depends upon deadline. So the first approach that can come to your mind is why not we schedule in increasing order of deadline, right? So this comes naturally in the sense that why it's better to complete a job which has a, you can say, earlier deadline, right? Because if you schedule it later, then it might give you a negative reward, right? Because if this guy has a, let's say, deadline of 1 and this guy has a deadline of 10, you're better off scheduling this guy first, right? Because if you schedule a task with a lesser deadline later, it will give you a negative reward. So this is just you can say thinking that can come to your mind, right? So one approach is scheduling in increasing order of deadline. But is this a valid strategy? So if this is a valid strategy, I need to give you a proof. But if I have to fail this strategy, I just need to give you one example. So let me frame an example and fail this strategy. You can fail this strategy if you just use little bit of your brain. So what you can do is, let's just say first we have a task which is a deadline of 1. Okay, so it has to be scheduled immediately. But it has a duration. It has a duration of 100. Okay, and let's say we have another task whose deadline is 2, just greater than it, but duration is small. The duration is simply 2. Now if you follow the strategy of scheduling in increasing order of deadline, what you'll do is you'll first schedule this task which has 100 duration. So initially it was 0, and you schedule this task which has 100 duration, so it will be completed at 100. This guy's deadline was 1, right? And then you will have to schedule this task with a duration 2, so it will be completed at 102, but its deadline was simply 2. Okay, so what is the reward here? If you calculate the reward here for this 100 guy, the reward will be what? It got completed, like its deadline was 1, but it completed at 100, so 1 minus 100, plus the second guy's deadline was 2, but it got completed at 102. So this is what? Minus 99 plus minus 100. So it is minus 199, right? So it is minus 199. Okay. But here, if you have done something like this, if you had scheduled the shorter task first, so it was 02, and then, so this guy had a deadline of 2, and then you would have scheduled this 100 guy, so this would have ended in 102. This guy had a deadline of 1. So here, what is the reward? You can clearly see the first guy, it will be 2 minus 2. Its deadline was 2, it got completed at 2, so d minus f is 2 minus 2. And then the next guy, it got like its deadline was 1, but it got completed at 102. This is simply minus 101. So this strategy doesn't work. Scheduling in increasing order of deadline. Fine, if increasing order of deadline doesn't work, then next logical step might be, will it work if I schedule in decreasing order of deadline? Now this looks stupid, right? Because why would you want to do this? If you schedule in decreasing order of deadline, then you're effectively inviting the negative reward. This can also be easily failed. Like, I think you can come with an example, but if you want, I can give an example here as well. Let me give an example here. Let's say we had a task whose duration is 4, and the deadline is 8, and afterwards we have a task whose deadline is 2, sorry, duration is 2 and deadline is 7. If we schedule in decreasing order of deadline, then what will happen? If you schedule in decreasing order of deadline, then this guy will be completed at 4, but its deadline was 8, and then this guy will be completed at 6, completed 6, but its deadline was 7. So the reward here you will get will be what? It will be 8 minus 4, 4, plus 7 minus 6, 1. Reward will be 5. Okay, but you can clearly see if you would have done something like this, 0 to 2, it had a deadline of 7. Then afterwards you would have scheduled this 4 guy, so it will be 6, but the deadline was 8. So here the reward you will get will be what? 7 minus 2, 5, plus 8 minus 6, which is 2, so 7. Right. So this strategy of scheduling in decreasing order of deadline also doesn't work. Then what? Then the next argument will be, if we have tried to play with deadlines, now let's try to play with durations. Okay. So yeah. So we're going step by step, right? So duration, but how do you make a decision here? So for duration, like, you can either have something like this, right? So we can have, let's say, this task X and this is a task Y. Okay, maybe let me draw it a bit more well. Task Y. So we can either have a task schedule like this, that is the larger duration task comes before a smaller duration task, or vice versa, right? Now pay your utmost attention here. What if we have something like this? A larger duration task is coming before a shorter duration task. But instead of this, if I just swap the order, that is, I bring this guy here and I bring this guy here. Oh, sorry. Let me do it again. If I bring this guy, bring this guy afterwards. Right. So what just happened here? Let's say the duration here was A and duration here was B. Okay. Now, in your schedule, if you have a larger duration task before a shorter duration task, if I just swap it, what happens, guys? This guy got shifted back by A, right? So I don't know where its deadline would be. But this guy is now getting completed A duration earlier. You agree with me there, right? So this guy got shifted back by A. In other words, in the reward, we had a gain of A, right? Why? Because this guy was completed somewhere here. I don't know what the time is. Deadline might be anywhere. But when it got shifted back, we definitely got a gain of A. Did you agree with me, right? Okay, fine. But this guy got pushed ahead, right? So this guy will lose something. This guy got pushed ahead by B, right? So we'll definitely have a disadvantage, or you can say you could decrement of B from a total reward, right? But all in all, we have a gain of A minus B, and you know that this A is greater than B. So what does this mean? If we have two tasks X and Y, we can always swap them. We can always swap their order in our schedule. And if we do this, we get a gain. Of A minus B. And you got it, right? So this guy got shifted back by A, right? So you got a gain in its, you can say, D minus F, right? So now this guy's finishing time is pushed back by A. So definitely in the total reward, there will be a gain of A. But this guy got pushed ahead by B, right? This will be ended, you can say, bit late now. So the reward will be decreased. Total reward will be decreased by B, right? Because it got pushed ahead. So all in all, in a reward, I'll get a gain of A minus B. And this is a gain. This value is positive. Why? Because this A was greater than B. So all in all, for every pair, for all pair of tasks, all pair of consecutive tasks, in other words, all pair of consecutive tasks, duration of Ti should be less than equals to duration of Ti plus 1. So it simply says you just process all the tasks in increasing order of duration, right? And the proof is right in front of your eyes. If you don't do this, you're better off swapping it. So if you don't do this, if you don't process them in increasing order of the duration, there will be a pair where first guy's duration will be greater than the next guy. But you're better off swapping them. In other words, simply process the task in increasing order of duration. So deadline is actually redundant. It's of no use to us, right? So yeah, I mean that's you can say the approach. You simply process all the tasks in increasing order of duration, and whatever the reward you get, you add it. So if you want to see the pseudocode here, I can provide the pseudocode. So what you can do is first we sort in ascending order of duration, right? And what do we mean by sort? So we have an array which will store all the duration and deadline, right? So we just simply sort this array. Since the duration is first, it will be automatically sorted by duration, and then we calculate the reward. So I can maybe initialize the reward to 0, and then a running finish time variable which keeps track of the finishing time of current job. So r is 0 and finishing time, let me go to ft to be 0. Then we can just process this you can say jobs in sorted fashion. So for let's call this duration deadline in jobs. Okay, first calculate the finishing time per current job, which will be ft plus equals to duration, right? So last finish time you had, so last finish time plus duration. So initially for first job the last finishing time was 0, so 0 plus equals to duration, and then we calculate the reward. So what is the reward, guys? The reward is simply deadline minus reward plus equals to deadline minus ft, right? And after the loop ends, you can just print the reward. What is the time complexity here, guys? This is sorting, right? So n log n is consumed here. This is simply a linear loop, so order of n. So all in all, the total time complexity is order of n log n for the sorting part. I should write more legibly, otherwise I might get cancelled. Okay, so this is n log n, and then order of n for the loop. The space complexity, like we are not using any extra space otherwise other than the input, so space complexity should be order of 1. So I hope like you got the explanation and the pseudocode, and if you did, please comment understood in the comment section of the video. And yeah, you clearly saw that the deadline was redundant, like it was not needed. So these are very, like you can say, peculiar things which are very hard to spot on. So as a matter of fact, I'll give you one exercise if you are really interested. If I change just one little thing in this question, the entire dynamics change. Okay, so everything I'm keeping saving this question, and let's say initially my reward function is defined like this, right? So my initially in this question the reward function is like this, simply d minus like di minus fi, right, for all i's. So this is my reward function in this question. So here we found out that simply performing the jobs in ascending order of the duration was the optimal thing to do. Okay, I'll change one little thing. Let's say my reward function is now looking like this. It is di minus fi, okay, only if di minus fi is greater than equals to 0. So if reward is positive, then and only then you can say we will calculate the reward. Otherwise the reward will be 0. So you won't get a reward if di minus fi is less than 0. In other words, if you complete a task later than its deadline, then you'll get a reward of 0. Now this seems like a very small change, and you might think that we can still sort it by the ascending order duration and make it work. But okay, I'll not tell you the answer. You tell me the answer in the comment section of the video. How are you gonna solve this question? So I just changed one little thing. Now the reward, whenever you complete a task later than its deadline, is 0. It is not di minus fi. So negative rewards are not there now. Now you tell me, how are you going to solve this question? Okay, but I guess we are done with this question, like task and deadline. Let's move to the coding part and wrap up this video. Alright, here's the code, guys. So first things first, I'm taking the input. So in the input, you can see I've created a vector of pair of intent where I'm storing the duration and deadline for each job or task, whatever. So I'm storing duration deadline as a pair. So duration deadline vector is updated here. Then I'm sorting this vector, right? And since you know that duration is first, this vector will be sorted in ascending order by duration first, and if durations are same, then it will be sorted by deadline. But it doesn't matter. if two tasks have same duration, it doesn't really change anything, even if you swap them or not, right? So all that matters is you have to process a smaller duration task first. Okay, so that's how you sort it by duration, and then uh, we first initialize the finishing time and the reward variable. Then we go through all the tasks in order of their duration. First, we find the finishing time of this current job, which is ft plus equals to duration, right? Whatever the finishing time of the last job plus equals to current job's duration, and then we update our reward. Okay, and in the end, we can just output the reward here. And what is the time complexity? It is simply the highest time complexity here is simply for the sorting, which is n log n, and this is just a const, you can say order of n loop, and space complexity is order of n. There's one little thing, we are using here long longs, right? And why are we using long longs? Because we are doing some addition and all, right? So just to avoid overflow, we are using long longs. So that's about the coding part. So I hope you got something out of this video, and do let me know your thoughts about the exercise question I gave you. And if you find this video helpful, please give it a thumbs up, and I'll see you in the next one.